Hello students. I'm skipping around a little and I'm going to begin with problem 10 from the Practice EOG today. This is a problem which asks us to multiply and divide exponents. First, let's review what we know about exponents. An exponent is the number of times a number is multiplied by itself. For example, when we see 3 raised to the second power, we know that 3 is being multiplied by itself 2 times. When we see a negative exponent, we know that number will become a fraction. A number with a negative exponent in the numerator or the top becomes the denominator. A number with a negative exponent in the denominator or on the bottom will be flipped and will become part of the numerator. For example, 1 over 2 to the negative third power would be flipped and would become 2 to the third power over 1 or 8. Similarly, 5 to the negative 2 in the numerator or on top would be flipped to the bottom and would become 1 over 5 to the second power or 1 over 25. How do we multiply and divide exponents? When exponents are being multiplied, as in question number 10, numbers with like bases are added, 2 positives or negatives, or subtracted, a positive and a negative. When numbers are being divided, such as a numerator divided by a denominator, the exponents are subtracted, bearing in mind the signs. Now let's look at the problem. In the numerator, or the top of the fraction, we see 4 to the third power multiplied by 4 to the negative first power multiplied by 5 to the negative second power. In the denominator, we find 4 to the fourth power times 5 to the negative third power times 5 to the 0 power. How will all these values fit together? In the denominator, we can combine the two base 4 terms, combining 4 to the third power with 4 to the negative first power. This simplifies to 4 to the second power, or 3 plus negative 1. We can also flip the base 5 value to the denominator since it has a power of negative 2. In the denominator, we can flip 5 to the negative third power to the numerator. The terms 4 to the fourth power and 5 to the 0 power remain in the denominator. The new expression will be 4 to the second power times 5 to the third power over 4 to the fourth power times 5 to the second power times 5 to the 0 power. Now we can simplify by combining like terms in the numerator and denominator. 4 to the second power in the numerator will combine with 4 to the fourth power in the denominator. The exponents are subtracted, leaving 4 to the second power in the denominator. Likewise, 5 to the third power in the numerator can be combined with 5 to the second power in the denominator, leaving 5 in the numerator. The value of any number raised to the 0 power is 1. So 5 to the 0 power in the denominator simplifies to 1. The new expression after this simplification is 5 divided by 4 to the second power times 1, or 5 divided by 16. We can divide this out and get a decimal equivalent of 0.3125, and this is the answer to the question. 5/16 or 0.3125 would be acceptable. In problem number 11, we're asked to find the value of a variable after various calculations have been performed in regard to the variable. The first piece of the calculation states that when 8 is added to the number that is produced by doubling the number x. What does this mean? It means take the variable x, double it, and add 8. The result of this piece of the problem is 2x plus 8. Next, we're told that this result, 2x plus 8, is 8 times the number that is 5 less than x. What does this mean? It means that 2x plus 8 equals x times, it means that 2x plus 8 equals 8 times x minus 5. Let's multiply these terms and we'll get an expanded equation. 2x plus 8 equals 8x minus 40. Now we can just solve the equation. Add 40 to both sides and get all of the numbers together. This gives us 2x plus 48 equals 8x. Now we can subtract 2x from both sides to combine like or variable terms. This gives us 48 equals 6x. If we divide both sides by 6, we find that x equals 8, and that is the correct answer. In problem number 12, we're asked to find the length of the sides of a triangle. We are told that the perimeter of the triangle is 76. Two sides of the triangle have lengths of 3m minus 4, and the third side of the triangle has a length of m. Let's remember what perimeter is. It's the distance around the shape. To find the perimeter, we add the length of the three sides of the triangle. Given that the perimeter is 76, the formula for the perimeter will be 76 equals 3m minus 4 plus 3m minus 4 plus m. We can combine like terms and get a simplified equation of 76 equals 7m minus 8. We can add 8 to both sides in order to isolate the variable. This will give the equation 84 equals 7m. Dividing both sides by 7, we learn that m equals 12. Line segment WX is 12 inches long. Problem 13 involves Kyle's pay as a salesman. He gets two types of pay, a flat salary and commission based on the amount of sales each month. Kyle's flat salary is the same every month. His commission percentage is the same and is multiplied by his sales total for the month. We'll call Kyle's flat salary X. We'll call Kyle's percentage of commission Y. In January, Kyle earned $2,550. This included his flat salary X and his commission Y times his sales of $15,000. In February, Kyle earned $3,050. This included his flat salary X and his commission Y times his sales of $25,000. Excuse me. We want to know Kyle's flat salary. It's a variable in each month's pay. We can take his total pay for the month, subtract his commissions, and this will give his flat salary. For January, the calculation would be $2,550 minus Y times 15,000 equals his flat salary. For February, it would be $3,050 minus Y times 25,000 equals his flat salary. Since each one of these calculations equals his flat salary, we can set them equal to each other. This would give us 2,550 minus 15,000 Y equals 3,050 minus 25,000 Y. We can add 25,000 Y to each side to get the variables on the same side. And if we do that, we will have 2,550 plus 10,000y equals 3,050. If we subtract 2,550 from each side, we're left with 10,000y equals 500. By dividing 500 by 10,000, we find that y, or his commission percentage, is 5%. He earns 5% for each dollar in sales. 5% of his January sales total would be $750. 5% of his February sales total would be $1,250. If we subtract $750 from his total pay in January of $2,550, we find that Kyle's flat salary is $1,800. If we subtract $1,250 commissions from Kyle's total pay for February of $3,050, we find that his February flat salary is $1,800. They are the same as they should be because he earns the same amount of salary each month, and that salary is $1,800. And that's the question that is asked. Number 14 is a linear equation, and we're asked to find the value of y when x is 0. This can be solved two ways. The first is to graph the points in the coordinate plane. If we graph them, we see that the graph is falling as we move from left to right, so that we know that the line has a negative slope. If we extend the line from x equals 3, where y equals 5, to x equals 0, we'll find that y equals 17. Another way to approach this problem is to examine the table. We can see that for each increase in x, or 2, y, it decreases by 8. The formula for slope is rise over run. In this case, the rise is -8 and the run is 2. The slope of the line is -4. If we decrease x to 1, y will increase by 8 to 13. To find the y-intercept, we decrease x by 1 to 0. This is half the run of 2, thus the rise will be half of the rise, or 8. This increases the y value from 13 to 17. When x equals 0, y equals 17. Number 15 is another exponent problem. The amount of trash in the ocean is 4.6 times 10 to the 4th pieces. The size of the ocean is 1.2 times 10 to the 8th square miles. To find the answer, we multiply 4.6 times 1.2 and we get 5.52. Multiplying the exponents together, we add 10 to the 4th and 10 to the 8th and get 10 to the 12th. The correct answer is A, 5.52 times 10 to the 12th. Number 16 asks us to find the cost of a ticket in 2000 if we know the cost of a ticket in 2005 and 2008 and the ticket price has increased at a constant rate. The ticket price has increased from $48 to $55.50 between 2005 and 2008. This is an increase of $7.50 in 3 years, or an increase of $2.50 per year. We can find the difference between 2000 and 2005 by multiplying the annual increase by 5, the number of years between 2000 and 2005. This gives us an increase of $12.50 between 2000 and 2005. Subtracting $12.50 from the 2000 price of $48, we find that the price in 2000 was $35.50. Number 17 is a time versus distance graph. Mr. Jones goes to visit his mother on Monday and makes the trip of 400 miles in 8 hours. This means that he was traveling at 50 miles per hour. On Tuesday, he returned home but increased his speed by 5 miles an hour. If he traveled 50 miles an hour Monday and increased by 5, then on Tuesday he traveled 55 miles an hour, and the correct answer is C.